consumer responsiveness to change in price is an important thing, because as business owners, as people who work for businesses, it's really important to understand how people react to the change in price of your particular good. And so that equation, the price elasticity of demand equation, really gave us that tool that we need to come up with a quantifiable number that represents how consumers respond to change in price. And so that is definitely that equation on the third slide, including the title of 5-1. That is definitely going to be something that you're going to want to have close at hand and know how to use when it's time for the exam, okay? You will definitely be required to do that. And then we have the example about tacos. And in this particular example, we were trying to measure the elasticity along the demand curve between the price of $1.10 and 90 cents. Whether we were increasing the price or decreasing the price between those two numbers, our elasticity would be the same. Because if you think about the equation where you're plugging in the two quantities and the two prices and coming up with the average and taking the absolute value, by the time you plug these numbers in, it would be the exact same elasticity if we were going from 90 cents to $1.10 than it would from $1.10 to 90 cents. So we're measuring how responsive consumers are to a change in price along that range of the demand curve, okay? And so we got a 0.5 and determined that when we looked at the different categories, inelastic, unit elastic, elastic, that was fairly inelastic, which meant consumers weren't being very responsive to that change in price. Now, for that particular example, we were thinking about decreasing the price. And we decided because consumers weren't being very responsive, we got that inelastic 0.5 that we actually shouldn't decrease the price because it would actually decrease revenue if we did. It's a good thing to know. It's a good thing to know. And so that brought us to this very last slide where we looked at a demand curve and a revenue curve at the same time. And we looked at them together. Yep.
I decided to join the Zoom instead of PowerPoints, but your slides aren't changing at all. It's just on the title slide. This is what we're seeing.
Huh. Okay, let me try sharing a different screen. Okay, is this one changing?
Yeah.
Is it changing now? Okay, yeah, sorry about that, guys. Okay. So this is being the equation, remember that you want to have ready and available. And then the last slide that we went over before we broke last week was something like this, right? Where we looked at the downward sloping demand curve, how it's more elastic at those higher prices and more inelastic at those lower prices. And then what happened to revenue as we decreased price and worked our way down that demand curve from highest price to lowest price. And we saw that initially in that that elastic phase, we saw an increase in revenue up to a point, that point where we hit unit elastic, perfectly unit elastic, and then revenue began to go down again as we began to experience inelasticity, right? And so just understanding the relationship between revenue and elasticity. So the next thing we're going to do is we're going to talk about what we call constant elasticity demand curves. These are highly theoretical. In practicality in real life, a lot of these don't exist in their purest form. but they're going to give you some interesting thresholds, I think, to compare other more realistic demand curves to. So this first one is going to be perfectly elastic. If we had a perfectly elastic demand curve, it would be represented as a perfectly horizontal demand curve, which meant that the price would remain consistent and the quantity would change, right? But price would remain the same all along that demand curve, that perfectly horizontal demand curve. What that would tell us is that consumers were willing to take all that was available for some given price, but that if we tried to charge them even a penny more for that thing, demand would go to zero. Now, in reality, is there any such a good? Well, I'm not really sure there is, but I can give you some good examples of markets in which we would see a mostly horizontal demand curve, okay? And that would be something like a share of a company's stock or an ounce of gold or something like that, that actually sells for some given going price. If I knew what a share of a company's stock was going to sell for, I wouldn't pay a single penny more than that because it has like a market going price, okay? And so while that demand curve might not be perfectly horizontal, it's going to be pretty close to it, okay? I'm not saying there isn't anybody out there who would be willing to pay a penny more. There probably would. But because we're talking about human behavior, having a perfectly anything demand curve isn't realistic, right? So perfectly inelastic would be a vertical demand curve, which basically would imply that you and I would demand some given quantity of that good, no matter what the price was. That the demand, the quantity demanded, would stay relatively consistent. We alluded to some of these goods in prior lectures. What goods did we say were in markets that would not see a lot of fluctuation in quantity? Whether it's more or less, that people don't tend to buy more or less of these things depending on price. Do you remember? We had some great examples. I would put something like a life-saving medication or a highly addictive substance in that category. You and I, if we need a life-saving medication, probably no matter what happens to the price, we're going to stay pretty consistent to the quantity we're buying. We might buy less of other things in order to be able to afford that. And we're also not going to buy extras. Because why would you buy extra medication if you really only need a certain dosage every day, right? And highly addictive substances we find fall into that same category as well. And then we have unit elastic, which ends up being this concave curve. Very unrealistic. This would just be some random coincidence. So I wouldn't worry too much about it. But here are the physical representations of those three constant elasticity demand curves. Perfectly elastic is horizontal, perfectly inelastic is vertical, and unit elastic would be this really nice concave shape where every single point along that movement from one point to another along that curve would all generate a perfect 1 when you did the elasticity of demand equation. What are the chances of that? Not very good, okay? So what are some of the determinants of price elasticity of demand? Well, there are a few. big ones. And I would say this first one is the biggest one, and that is the availability of substitutes. It's why I said that taco was not a good example, because tacos do have a lot of substitutes, right? A, everything else on the menu, or B, any other food item that you are willing to substitute in and out of your consumption, okay? And so the greater the number of substitutes available for that good, the greater the elasticity of that good is going to be, because consumers can respond to changes in price by going and getting something else or consuming more of that good. If there's not a lot of substitutes, there's nothing you and I can do about being responsive. You know, we just have to live with it, okay? The second one, share of a consumer's budget spent on that good. So the more significant that good is in your overall budget, the more responsive you're going to be to a change in price of that good. So for example, if your rent goes up by 10, 20, 30%, you're going to react, because that's probably one of your most significant bills every month, right? And so you're going to start looking for other places to move because of that income effect. Now, if it's your Starbucks, yeah, not that big of a deal. Okay, so you're going to tend to be more inelastic about that. And the last big thing that we find that is a determinant of elasticity is the length of time you have to make adjustments. So if you think about gasoline, for example, I own a car, right, that I just bought recently, and the only fuel it takes is gasoline. So if the price of gas quadruples, I still have a car that requires it. And so my demand will not be that elastic. But you give me a few more years when I go to buy my next vehicle, and I may choose something different in terms of energy source. I may choose an electric car, or by that time we might have solar cars, whatever. But the more time I have to react, the more reacting I can do, okay? This is just that last determinant, okay? Explained a little deeper. Elasticity is greater in the long run because consumers have more time to react to a change in price. Price elasticity of demand is about reaction, right? How are the consumers reacting to a change in price? All right, let me pull up the next PowerPoint. So we're going to move on to 5-2. All right, so you should see 5-2 come up. Okay, so we have switched from talking about price elasticity of demand to talking about something we call price elasticity of supply. In my mind, not nearly as important of a topic, but important to a small segment of the population for various reasons. So price elasticity of supply just measures how responsive producers are to changes in price. Now, we know that if you offer producers a higher price, they want that profit, and that does encourage them to produce more. But it's not that simple, right? It never is. But what this does is it measures elasticity of supply in different markets. It is exactly the same calculation as price elasticity of demand. You just use data off the supply curve instead of data off the demand curve, okay? It is always a positive number. You don't even have to take the absolute value at the end, and it's always going to be a positive number, okay? Because your variables move in the same direction. Your price and quantity go up together or go down together. And so either way, you end up with a positive number, even if you don't take the absolute value, okay? So this is gonna look familiar. It's the same equation, but instead of elasticity of demand, this says elasticity of supply, but it is exactly the same calculation in terms of plugging in your changes in quantities, your average quantities, change in price, average price, okay? Elasticity of supply is always positive because price and quantity move in the same direction. So you can see on a graph here, we're not gonna go through and do an example, but this is just to kind of show you that they move in the same direction, sort of give you that physical illustration, that visual for you to see. And then you can see that the categories of elasticity are exactly the same as they were with price elasticity of demand. So a lot of this stuff remains constant between these two equations. You're just evaluating them a little bit different in that you're pulling those quantities and prices off of a different curve, but it's basically the same analysis, okay? So in other words, if you get something, it's always a positive number, right? But if you get something between 0 and 1, it's going to indicate that we're not seeing a lot of responsiveness from suppliers. Unit elastic would simply be a coincidence, right? Which would be a 1. If you get a 1, and anything greater than a 1 is going to indicate elasticity or suppliers being very responsive to change in price. Being a supplier and responding to a change in price is complicated, right? There are a lot of different factors that suppliers would have to take into consideration to determine how elastic they could be to changes in price. And we'll get there in a minute, but it's a complicated discussion. So just like the demand curves that you saw, there are also constant elasticity supply curves. They look pretty similar in that a perfectly elastic supply curve, again, would be perfectly horizontal. What this would mean, a perfectly horizontal supply curve, is that suppliers would demand a certain price and actually would not accept a price a penny lower than that. Not entirely realistic. Chances are there would be a supplier that would supply product a penny less than some given price. But again, you would be talking about those markets in which the goods had a given price. If you knew that an ounce of gold sold for X number of dollars per ounce on that day as a supplier, why would you supply less than that? It's the going price, right? Not entirely realistic, but still sort of gives us a threshold or a boundary conceptually about where that would exist. Perfectly inelastic supply would be perfectly vertical, which means at some given quantity, that supply curve would come straight vertical out of that x-axis, which would indicate that at any given price, supply would still remain the same. This is very realistic. What would be an example of a good that supply would remain perfectly consistent regardless of the price that was offered? Any thoughts? Any thoughts at home? Okay, so Devin says gas. Devin, to some extent, I think you're right. There is some gas that I'm gonna use some quantity of gas regardless because it's a necessity. But then there's a portion of my gas consumption that I might rethink. Okay, so I like where you're going with that. What else? Water, because water is in, I guess, limited supply. Yeah, I'm not really sure. I'm not really sure, but yeah, there is some given quantity of water available, right? I guess there might be a given quantity of gas available, but I would think the price of gas got really high, right? Suppliers would try and give us more. Electricity, maybe. I would think something like a 1965 red convertible Corvette is not going to have much of a change in supply regardless of price. So things that are in finite quantity. Is water, gas, and electricity in finite quantity? Probably at some extreme it is, right? But for now, we probably could encourage production by giving higher prices, okay? All right, and then unit elasticity is actually a straight line from the origin. Again, it would just be a coincidence. We're not going to see anything like that very often, right? So here, sort of the illustration of those three. Again, pretty unrealistic in their perfectly horizontal or vertical or perfectly sloped line, but they can give you some thresholds. If you see a supply curve that seems to be a little bit more on the vertical like angle, you know that that good as a whole is more inelastic than a good that has a supply curve that is more horizontal, right? And so there is a question on your homework that asks you to do this, and I can't remember if it's supply or demand curves. It doesn't matter because they both look the same, right? Elastic is horizontal, inelastic is vertical. So it's going to have you compare two curves and two goods in two markets and say, which one of these goods is more inelastic? Which one of these goods is more elastic? Well, how horizontal or how vertical are they? That would be my first indication, okay, as to what end of the spectrum that lies on, okay? Okay, what determines supply elasticity? I gave you one here, but there's actually a bigger list than this. This is actually an opportunity for us to talk about some of those things. But one thing that remains constant between a determinant of supply elasticity and demand elasticity is length of adjustment period. You give a supplier more time to make more, they can make more. But there are some other very critical things that would determine price elasticity of supply. What would those things be? What things can you think of that would be really important for a supplier to use to determine how they can react to a change in price by supplying? What kind of things can you think of? Any thoughts? Yep.
Changing technology.
Change in technology, absolutely. As technology changes, especially for suppliers, right? It changes their ability to give you more. Great. What else? What would change either an individual supplier's or a market supply in the case of a price change? What would determine how quickly suppliers could respond? Can you get your raw materials? Is there even any resources available for you to then take and make your good with, right? I would say things like spare capacity. Do you even have a factory or an operation that can supply more? Or are you maxed out, right? Do you need to build a new factory? Do you need to build a new warehouse to be able to store all that stuff in? Yeah, that is the length of adjustment period. So that does speak to, you give us more time, we can produce more goods. But there's very specific things that must be thought about, right? Availability of inputs, price of inputs. How long does it take you to produce another unit? Do you make something that you can produce in a minute, or do you make something that takes you months to produce? That's going to determine how responsive you can be to change in price, right? Okay, so let's move on to a couple other elasticity measures that I think are pretty interesting, that are a slightly like new hybrid of this price elasticity of demand and supply thing, but really cool and can tell you a lot. So this first one is something we call the income elasticity of demand, which goes through and does an analysis that has to do with how responsive people are when their income changes. So how their demand changes when their income changes. Well, we've already talked about this a little bit when we talked about the law of demand, right? We know about inferior and normal goods. And that with normal goods, as our income goes up, we want more. And with inferior goods, it's the opposite. The more money we make, the less of those things we want. And those are things like ramen and generic goods and used goods and bus tickets and things like that. Well, if you're not sure what kind of a good you actually have, you could run some of these numbers and you could figure out if you actually do have a normal good or an inferior good, or how close to that threshold you are. If yours is very normal or very inferior, right? How responsive are people to your good when their income changes? And so the equation for that, percentage change in demand, quantity demanded, divided by percentage change in income. So instead of changing price, we're changing income, and then we're seeing what happens to the quantity demanded as a result. With the next two measures, it's actually going to be important to keep your negatives, right? If you see negatives, because that's actually going to be able to tell you something, okay? And so let's go through and do a quick example here, okay? I'm going to do one up on the board here. For this income elasticity of demand, okay? The thing I'm gonna do though, is I'm not gonna use the midpoint formula. The midpoint formula is the formula you've been using for price elasticity, demand, and supply. It's where we took that average. That's called the midpoint formula, and it calculates elasticity over ranges of numbers. We're not gonna do that here. We're gonna take a slightly different approach to that, okay? But let me kind of set you up here. Okay, let's say my income is going from 100,000 to, let's do 110 to 110,000, okay? And if you're selling a good, let's pretend your market, the people in your market have seen an income increase from 100 to 110,000, okay? Because maybe that's a better way to look at this, okay? The thing you would want to do is not calculate this for yourself, but calculate this for your company, your good, okay? Let's say we're in the company of producing wine or selling wine retail or something like that. And we have done market research, or we have data that would suggest that when people's incomes go from $100,000 to $110,000 a year, they go from consuming 40 bottles of wine per year to 60 bottles of wine per year, okay? It's probably a pretty realistic number, right? It's less than a bottle a week. And then if we did the calculation not using the midpoint method, remember it's percentage change in quantity demanded. So demand over the percentage change in income. This is a D demand, okay? Over percentage change in income. Does anybody remember how you calculate just percentage change? Not using the midpoint formula, just percentage change. Any thoughts? I know it's been a minute, right? The amount of the change over the original amount. The amount of the change over the original amount, okay? So let's do quantity demanded first. Amount of the change, 20. Our original amount is 40, okay? We've been using the midpoint method here. We add them together, divide by 2 to come up with an average. We're not going to do that here. I actually know that people in my community have had a $10,000 increase in income. So I'm not interested in what happens along this range. I actually want to know exactly what happens when they get that $10,000 increase in income that they got, okay? So this is a lot more specific than the midpoint method would use, okay? All over change in income, which is 10K, over our original income, which was 100,000. Now you just do the math, right? So we have 20 divided by 40, which gives us what? 0.5, thank you. 10 divided by 100. Thank you, 0.1. 0.5 divided by 0.1. Try not to make the math too hard here, people. 5. Okay. So if we go back to our PowerPoint, we can see that any elasticity greater than 0 is going to indicate we have a normal good. So we have a 5. So we know that wine's a normal good. Well, that's pretty obvious, right? We probably could have guessed that. But not only is it a normal good, it's almost excessively normal, right? The more money, it is directly related to people's incomes. The more money you make, the more wine you buy, almost exponentially, if you will, okay? And then you can see, we can take it one step further. If the elasticity is less than 1, so between 0 and 1, it's income inelastic. And if it's greater than 1, it's income elastic. Consumers are very responsive in terms of wine consumption as their income goes up. Well, this was a good example because it turned out kind of the way we would expect it to, okay? All right. And then the last measure is something we call cross-price elasticity of demand. Cross-price elasticity of demand. This is a calculation that would help you determine or confirm a relationship between two goods in terms of, are they substitutes, are they complements? Cross-price elasticity of demand would actually look at the price change of one good and how it affects the quantity demanded of another. So the percentage change in the demand of one good divided by the percentage change in the price of another. So it's still that quantity price calculation, but you're matching up two different goods. The price change of one good and the quantity demanded of another. In this particular example, you would want to keep the negatives because the negative would actually tell you something. Getting a negative cross-price elasticity of demand would indicate that you are talking about substitute goods. You are talking about goods that can be replaced with another good. So Coke and Pepsi was our previous example for substitutes. If a price decrease or increase of one good affects the substitute, right? And you get a positive number, you actually confirm that they're substitutes. So listen to this, okay? Remember how we talked about if the price of a substitute drops, right? It's going to increase the demand for a good of that, or demand for that good, and decrease the quantity demanded of the other. So the price went down here, and the quantity demanded went down here, both moving in the same direction. That gave us a positive result, okay? It's just the math. And then if we got negatives, they would be complements. So complements, that's the hot dog bun example. So remember their demand, quantity demanded moves in the same direction. That even if price changes of only one of them, so your hot dogs go up in price, right? The quantity demanded for both is going to go down. That is an inverse relationship, right? Price of one goes up, quantity demanded for both goes down. You're going to end up with a negative. And so you're going to be able to confirm that those two goods are complements. It is really, really, really important for you to understand if you produce a good, whether you have substitute or complement goods on the market that can impact your good, right? That's super important because it has nothing to do with your own price changes. It has to do with the price change of other goods that impact you. Pretty important thing to know. If you end up with a 0, then you know your good is not related to that other good at all, and then you don't have to worry about that relationship, okay? All right. That's all I have. Any questions from anybody about this or about your exam or anything else? All right, guys.